Section 5.4 is all about solving radical equations. So we're going to use our properties of rational exponents and everything we've learned so far to accomplish this goal. For example, 1, we just have an equation with one radical in it. So your steps here. First thing I want to do is get the actual radical by itself. So in this case, I'm trying to get the square root by itself. That means I got to move the -1 to the other side. Remember, whenever you go from one side to the other, go ahead and do the opposite. So instead of -1, add 1. Gives me the square root of x plus 5 equals 4. From there, we have to get rid of the radical. So there's two ways you can go about doing this. You could either use rational exponents, or personally, I like to think of just opposites. In this case, the opposite of a square root would actually be squaring each side. When you square square root, it's gone. Just left with x plus 5. 4 squared, you're going to give me 16. From there, you minus 5 from each side. You end up with x equaling 11. In this section, so when we're solving with radicals, you also want to get in the habit of checking your solutions. If I go ahead and plug 11 back in, 11 plus 5 is 16. Square root of 16 is 4. 4 minus 1, 3. So we're good to go. We got the solution x equals 11. B, same deal. Okay, you have one radical going on here, so it's not the end of the world. I got to get rid of that plus 2. Opposite of plus 2 is minus 2. Gives me the cube root of x equaling 2. From there, opposite of a cube root would be raising each side to the 3 power. Cubing a cube root makes it go away, so I'm left with x. And then 2 cubed is going to give us 8. You go ahead and plug it back in to check. Cube root 8 is 2. 2 plus 2, 4. So we are good to go. That's example 1. It's the easiest one we'll run into. Example 2. Actually, we don't have example 2. We go straight to example 3. Example 3 brings up the reason why we're actually checking our solutions here, because we're going to run into extraneous solutions on these. So with this, you have to identify where a radical is. Radical is on the left-hand side, so it's already by itself. There's nothing else with it on the left-hand side. In order to solve, we need to make that radical go away. Opposite of a square root, squaring. So when I square the left, I'm left with 3x minus 2. Square the right, I'm going to have x minus 4 squared. Remember, this x minus 4 squared, that 2 right there, is telling me that I need to write it out twice. X minus 4 times x minus 4. Since there's a minus sign in the middle, you can't distribute that 2 in. Only time we can distribute the 2, the exponent in, is when there's no addition or subtraction in there. So you go ahead and FOIL that out. And hopefully by now, we're halfway decent at that. Left-hand side stays the same, 3x minus 2. Right-hand side, when I FOIL this out, x and x gives me x squared. I got negative 4x, negative 4x. That's going to be a minus 8x. Negative 4 times negative 4 plus 16. Okay, back to first semester. We see we have an x squared, so that tells me to get everything to one side. Moving the 3x over, you do it by subtracting. So we're going to have x squared minus 11x. And then to move the minus 2 over, you go ahead and add it to each side. Plus 18 equals 0. Okay, when you have your quadratic, in this case, which is equal to 0, we go ahead and factor. So we want to know what multiplies to give us positive 18 and adds to give us negative 11. It's going to be 9 and 2. It's going to be a negative 9, negative 2. And then from there, we break them and solve. X minus 9 equals 0. So we get x equals 9. X minus 2 equals 0. So we get x equals 2. Okay, these are our possible solutions, all right? Like I said, for example 1, though, in this section, we need to make sure we check. So down here checking, we plug back into the original. If I plug 9 in, we get the square root of 3 times 9 minus 2 equals 9 minus 4. 3 times 9 is 27, minus 2 is 25, so I get the square root of 25 equals 5. That's good. So the 9 works out. That's a possible solution. X equals 2. Go ahead, plug that in. Square root 3 times 2 minus 2 equals 2 minus 4. 3 times 2 is 6, minus 2 is 4, so I get the square root of 4 equals negative 2. Does the square root of 4 ever equal negative 2? Like, what's the square root of 4? Square root of 4 is 2. That does not equal negative 2. So since it does not, we get rid of x equals 2, and we say that would be the extraneous solution. My only solution that actually works out is x equals 9. And we're not going to worry about the graphing of that this year. All right, last example we're going to look at is with rational exponents. Okay, so with rational exponents, you need to, first off, make sure the rational exponent is by itself. So we need to minus 4 from each side, giving us x squared plus 5x plus 5 to the 5 halves equals 1. From there, we have to get rid of that exponent. So to get rid of the exponent, you need to flip it and raise each side to that power. So instead of 5 halves, I flip it, raise the left-hand side to 2/5. When you do that, it's gone. Raise the right-hand side to 2/5. So with this, you take the 5th root of 1. What times itself 5 times gives me 1? It's 1. All right. From there, 1 squared is 1. So this one works out pretty nice. You're able to drop everything down. You get x squared plus 5x plus 5 equals 1. Okay. Just like we did on the last one, when I have an x squared going on, you go ahead and subtract 1 from each side. So subtract 1 from the right, 1 from the left. And when we do that, you get x squared plus 5x plus 4 equals 0. We go ahead and factor. So what multiplies to give us 4 and adds to give us 5? The x plus 4, x plus 1 equals 0. And then with this, we're going to get a solution, or solutions, possible solutions of x equals negative 4, x equals negative 1. Okay, those are my possible solutions. On these, when you have rational exponents, I'm actually going to check them on the calculator just because it's easier. Okay, so I'm going to type in exactly what it looks like. You have negative 4. We're plugging in for x. So in parentheses are real important here. You got negative 4 squared plus 5 times negative 4 plus 5. And then we are raising that whole parentheses to the 5 halves power. Okay. Last thing I do on the end is add 4. When I do that, it equals 5. Okay, so that's what it looks like in the calculator. Get rid of the glare. Okay, I worked it all out for negative 4. Plugged it in. Got it to equal 5, so we're good. You're going to do the same thing for negative 1. So parentheses negative 1 squared plus 5 times negative 1. Plus 5, raise that whole thing to the 5 halves power, and then again you have to add the 4 because we have a 4 there. Both of these do equal 5, so we're good. They're both solutions. Okay, the last example, for example 4, looks the trickiest, but it actually isn't the end of the world. Each side, rational exponents are by themselves. Okay, there's nothing outside the parentheses, so we can attack it. I like to get rid of the fraction. The way we get rid of the fraction is just flipping it, raise both sides to it. So I'm raising both sides to the 2/3 power. Left-hand side's gone. Okay, I'm just left with x plus 18. right-hand side. Remember, when you raise an exponent to another exponent, it's multiplying. Okay, so in parentheses, I have x minus 2 raised to the 6/3 power. 6/3 can be simplified to 2, so that gives me x plus 18 equals x minus 2 squared. Like we did earlier in this video, remember x minus 2 squared is the same as x minus 2, x minus 2. So you have to FOIL that out. Left-hand side is still x plus 18. Right-hand side is x squared minus 4x plus 4. Get everything to one side. So you subtract x from each side, give me x squared minus 5x. Subtract the 18 from each side, gives us a minus 14. Okay, back to our factoring skills. What multiplies give me negative 14 and adds give me negative 5? It's x minus 7, x plus 2. When we solve it, we get possible solutions of x equals 7, x equals negative 2. Okay? And then, like I said before, you are going to check on calculator. Okay, so what that means, we're just plugging in. Okay, so if I start with the 7, wherever I see an x, I'm plugging in 7. So we go 7 plus 18, raise that to the 3/2. So I get 125 on the left. Plug it on the right-hand side. We get 7 minus 5, and we are cubing that. Not 7 minus 5. 7 minus 2, and we are cubing that. We get 125. Both sides are equal, so we're good. Go ahead and do the same thing for negative 2. So parentheses, negative 2 plus 8. Raise it to the 3/2. Gives us decimal, crazy decimal. Probably would have helped if I actually would have typed it in right. So let's do it again. Negative 2 plus 18. Raise it to the 3/2. Gives me 64. Okay. And then on the other side, you have negative 2 minus 2. Raise it to the 3rd power. Negative 64. Okay. A positive 64 is not the same as a negative 64. So what that tells me is that negative 2 is extraneous. The 7 was good. And that's section 5.4.